Okie dokie, catalysts. They're not the nicest of things, but there are key facts that you can remember for this. So we're looking at how catalysts affect the rate of reaction. So I've written up here some important bits about catalysts. There are chemicals. You add them to a particular reaction and they speed up that reaction. That's the main crux of it. That catalyst isn't used up, it's not part of the reaction, it doesn't form part of the products, it just speeds up the reaction. It does that by lowering the activation energy. That's the amount of energy needed to actually cause the particles to react. Do you like the monkey? It is a bit distracting, isn't it? So we should... Anyway, right, so here, let's say this is a catalyst. Now, catalysts normally tend to be transition metals, and they've got sort of divots in them, these sort of holes, and they work by holding on to one of the reactants, letting the other reactant bonk into it, look there. So it lowers the amount of energy needed because these things don't have to whiz around all over the place. They can just hold on to it and these will bump into them. So they have a specific shape, not that mine are beautifully drawn because they don't look particularly good, do they? Oh, we could just scrape them in there. So if I try to do it with this reactant, one that stabbed the monkey here, it ain't going to work, look, because it doesn't fit. It's not the right shape for this catalyst. So you'd have to use a different catalyst for this one. So they are specific, so that's important. So they are specific, which means that they only work for one particular reaction. They're only right shape for one particular lot of reactants. They are reusable, that once you've done your reaction, then you can use them for another one. Okay, let's look a bit more about this activation energy. This is more higher tier now. What does that actually mean when it says it's lowering the activation energy? Well, hopefully, let's just move this a bit, sorry. This here, this graph, is about amount of energy in a reaction against the time. Now, if I start a reaction and say, right, these particles have about this much energy in, I've got to say, let's think it was magnesium trying to react with the oxygen. Don't look at the dogs, you're supposed to be looking at this. Right, now you're looking at the dogs, aren't you? Look at this. Right here, this amount of energy, then I have to burn the magnesium, I have to put some heat in. So this is the amount of heat I needed to put in, amount of energy, to cause them bonds to break. You don't need to know this, this is trying to explain why it lowers the activation energy. So this is the amount of energy I had to put in to get that magnesium to react with the oxygen in the air. Then the magnesium burns, releasing massive amounts of energy, all this energy, okay, all that energy there, much more out than is in. So, and then it finishes. So this amount of energy that I had to put in, that sort of burning bit, a catalyst will lower that amount of energy. So if I do it with a catalyst, the same thing, I'll lower the amount of energy needed, still give the same amount, and therefore this bit of energy here, this part here, is lowered. That's the activation energy. Therefore it's going to go quicker. If you imagine here, like this dog is going to jump over the small here wall. It's going to be able to do that a lot quicker, not that it really can do it at all, but than this one here. So a catalyst lowers the wall, lowers the amount of energy needed for the reaction to happen. So if we go back, let's put this frame back on. So they can be used, they're sort of metals, they're used for specific reactions, and you can use them again and again. In real life, we use catalysts here, this stuff here, this is sort of like a puncture repair kit. There's glue and there's a hardener, and the hardener is the catalyst. There are chemicals in here that will react together, but only with enough energy to react. So if we add the catalyst, they then react and form really super duper glue. And then this here, sorry, this, imagine that this is the reaction in here. So let's put some green particles in, and they are reacting with some black particles. I put my catalyst in, it all reacts, and then I'm left with my catalyst sitting at the bottom. How am I going to get it out? Well, I filter it all, and then I can reuse it. Okay, so you take the catalyst out by just filtering it out. So industries use this all the time to lower the amount of energy they need to cause a reaction. So they add the catalyst, the reaction's a much lower temperature, and then it's much cheaper. Okay.